Hello and welcome to my channel The Complete CSC Guide, and I am Sanskriti, your guide. In today's class I am going to tell you about the data link layer functions, that is the first function, that is framing. As we all know that in data link layer the main thing is frames, right? That the bits which comes from the upper layer, from that first of all we are starting from the physical layer, so the bits which are coming to the data link layers, they are then converted to frames, right? So in the data link layer, basically the thing which is important, that is the type of data we use here, is the frames, right? So first of all we will see here what is framing. So framing is the data link layer packs bits of messages into frames, right? And each frames is distinguishable from one another, that we can understand that which frame is coming from which source and it's going to which destination. But each and every frame is different from each other, okay? And this data link layer, what it does, it makes the bits of messages, it converts it to frames, right? And now whole message is not packed in one frame. Whenever we are packing the messages or bits, we are not packing whole messages in one frame only. Why we are not packing the whole message in one frame? Because if any kind of error occurs and we have a whole large message, if any kind of error occurs in that particular portion or a particular frame, a small bit error, we have to retransmit the whole frame, right? That is, if frame is very large, flow and error control will be inefficient. The flow control will be inefficient and the error control, both functions will be inefficient. So whenever we are going to just convert the whole message bits into frames, what we do, we just take small portions, small messages, and we convert them to frames. But we doesn't take a large portion, or we are not converting a whole portion, whole message into a frame. We are not packing that one, right? So here, if frame is very large, then your flow and error control will be inefficient. Then if a message is carried in a very large frame, single bit error will require retransmission of the whole frame. Is some kind of, we will see the protocols also, different protocols will be shown by me to you, and that time what will happen, if some data is retransmitted, if some error occurs, then what we have to do, we have to retransmit the data, right? So whenever, if the frame is very big in size and if a single bit error occurs in your particular frame, what you have to do, you have to retransmit the whole frame, right? So if it will be larger in size, so for a small bit error you have to retransmit the whole larger frame. But if your frames will be smaller in number or smaller in size, then if some single bit error occurs, then a small portion will be affected. The whole message will not be affected, which will be beneficial for you only, right? So if message is carried in small frames, single bit error affects only that particular small frame. Then big frame, what will the problem? For a single bit error, whole frame have to be retransmitted, right? For whole frame, it's very typical for you to retransmit the whole thing. So if small error is there, that small portion is affected, that will be more efficient than this particular one, okay? So framing separates a message from one source to a destination by adding a sender and destination address. Obviously, a frame has a sender address and a destination address, which makes it different from each other, right? So each and every frame, they have a sender address from which it's sending, and the receiver address where it is received. So this is happening here. Now destination address, where the packet have to go, where your packet is going, that is your destination address, and the sender address help the recipient acknowledge the receipt. After you will send the message, suppose here it's the sender and here it's the receiver. So what will happen if the sender is sending any frame to the receiver? After receiving the frame, the receiver will obviously send a acknowledgement. It will send a frame, suppose, then it will send the acknowledgement that yes, I have got your frame. The frame, what will be the sequence? The same sequence is received, then they will send the acknowledgement. But if the thing is not sent, if some bits are missing here, then it will send a negative acknowledgement. It will show that these particular frames are missing. So this kind of thing happens, okay? So you will see there stop and wait protocol, go back and protocols. The different protocols are there. We will discuss that later. But this is what is happening here, that if the sender is sending, that is the sender who is sending, and the destination address is the address where the particular things are received, right? That the frames are received, but the sender address, which is that one, receiver address, where the, or the destination address where the frames have to go, and the sender address is which one, where, from where the frames are sent. Not only that one, but also the receipt, the acknowledgement is received by that particular sender. So sender is the recipient of the acknowledgement, right? Now, frame size. Frames can be fixed or variable size. Any size can be your frame. Then fixed size frames, they are called as cells. No need for defining boundaries, since it's these are particular frames that are of fixed size, so your boundaries are not to be needed, not to be defined. Okay, since we know that this is of a particular size, but the size itself can be used as a delimiter. So when you are telling this is the size of my particular frame, so since it's a fixed size frame, so you have not to tell a particular delimiter. The delimiter will be only the size of the frame. So you have not to fix any boundaries for the beginning and ending of the frame. You have not to fix any boundaries, since the size of your frame will be the delimiter. It will show only the which one is the beginning and which one is the end of your frame, right? Then again, variable size frames need to define end of one frame and the beginning of the next frame. Since it's a variable size, it is needed that you have to show which is the end of your frame and which is the beginning of the next frame, right? And byte oriented and bit oriented approaches are used for this kind of particular framing. For your variable size framing, fixed size framing, you don't need that one. Okay. Now, for character oriented framing, what is that one? Character oriented or byte oriented framing, data is to be carried out are 8-bit characters. Basically here what the data is going to be carried out, that is 8-bit character data. Okay, whatever frames you are sending, that is that are 8-bit character data. Now, to separate one frame from next 8-bit, 1 byte flag is added to beginning of and end of the frame. Now, how you will differentiate between different frames? Suppose this is my first frame and this is my second frame. So, how you will differentiate between these are 8 bits and again these are 8 bits. So, how you will differentiate between them? So, you have to just stuff one data. That is, for separating this, you have to just give one first to separate one frame from next. 8-bit flag is to be needed. A flag is given, that is showing the beginning and end of a frame. So here a flag will be there and here a flag will be there. Again, this will show, this will differentiate one frame from another. Since these are variable in sizes, so obviously you have to show the boundaries, you have to show the delimiter. Okay, so here to show that particular frame which is my beginning and which is my end, some flags are added to this particular 8-bit frames, right, or 8-bit your character data. Now again, here flag is composed of protocol dependent special characters signal, that is the start or end of a frame. So here the flags are basically, they are 8-bit data and they are special, they have some special characters also. Okay, and obviously they are known as that protocol dependent special characters. Okay, how this is happening? Suppose this is my particular frame and now here this is my flag sequence. Again here my flag sequence is there. So here is my header and here is my trailer, right? And in between the messages are there. Okay, so here what is happening, from the header to trailer, a variable number of characters are there, and from here the data is coming from the upper layer, right? So to distinguish between this one, what we have to do, we have to insert these flags. These flags will show that how your data is different. So it will show you the beginning and the ending particular sequence, will show the beginning of and ending of your particular data, right? So this is needed here. Any character used for flag can be a part of the information. What is the wrong here? That is, any character here can be, which is used as a flag, can be the portion of your particular message or your particular data. This is the problem here. What is that? Any character which is a part of your information only. This is your information, right? This is your info. So this is the part of your info, but this flag can be the part of your information, right? So what will happen? Any character which is here can be used as a flag. Also, it can be a portion of your information. But if this happens, if this is happening in between, suppose here in between, this is the whole thing. So this is my beginning and this is my ending. But this flag sequence can be portion of your particular, suppose your particular information also. Okay, so if this is particular information, is the portion of your particular information, then what can happen if in middle this is my portion of my information, if this particular sequence, okay, this comes in between my particular message, then what will happen? The receiver will think that yes, this is the ending of the data. Starting, he is finding the message is coming, he is getting the starting point, but whenever the message is going on, in between, if this flag sequence is also a portion of your message, then if this flag sequence is encountered by the receiver, what he will think that yes, the end of the message has came, but it is not the reality. Since it's a portion of your message only, this flag sequence, so obviously if this can come in between also in the middle portion, but since the receiver is thinking is it as the ending of a message, he will think that yes, up to this particular portion the message has ended, but it's not the reality, the message is ending here. So this is the problem what is happening. So for ending this particular problem, bit stuffing or character stuffing is used. What is done there? Bit or character stuffing, process of adding one extra byte whenever there is a flag or escape character in the text. So this portion, what they do, if this kind of thing happens, if this flag comes in between, then what we do, we add an extra bit that is known as the escape character, right? So here, process of adding one extra byte whenever there is a flag or escape character in the text. So that is known as your escape character, right? It is escape character. If in between this flag sequence comes, then a escape character, that is a single bit, is added. Okay. Now here special byte is added to the data section of the frame when there is a character same pattern as flag. If same pattern as flag any character comes, then a particular byte is added to this particular portion, so that this will show that this, if some escape character is coming here, this will show that it is not the end of the message, but it is similar to the ending, similar to my flag sequence, but it is not the end of my message. Okay, that's why this escape character is used here in byte stuffing or your character stuffing. Okay, now data section is stuffed with an extra byte called escape character, which has a predefined pattern. This escape character also has a predefined pattern. Okay, these have a predefined pattern which will show that yes, it is not the ending, but it is a flag sequence which is coming in middle, but it's not the end of the message. Now, whenever receiver gets it, it removes it from the data section and treats the next character as data. Now, what will the receiver do? If this kind of escape character is received and the flag sequence similar to the flag sequence something is received, then it will remove it and it will go to the next section and the message will go on. So, this is the thing what is added in byte stuffing, that is your character, escape character. Okay, so why this is used? Since the flag character same to the flag pattern, some pattern is coming in middle, which will show the receiver. The receiver will think it as the end of the message, but it's not the end of the message. To show that one to the receiver that he doesn't resembles it as the last character or it's the ending of the message, we are adding an extra bit, that is extra byte, that is the byte stuffing. We are stuffing some byte in between, that is our escape character. Some character stuffing is done, that is your escape character, which will show it's not the ending of the message. The receiver will receive that one, it will remove the character and it will go for the next section. So this is what is happening in the byte stuffing or character stuffing. Very simple. Okay. Now next is your bit oriented. Okay. So bit oriented framing. First one is your byte oriented framing or character oriented framing, where we are using the byte stuffing or character stuffing. Now bit oriented framing, here the data section of a frame is a sequence of bits to be interpreted by the upper layer as text, graphic, audio, video and so on. Here we are taking a particular sequence. Here we were talking about a particular byte, a section. Here we are talking about a particular section, that is the data section of a frame, which will be resembled as some audio, video, graphic, data, English. So here it's a sequence of data. As you can see here, it's the flag and it is also the flag. So ending and beginning is given here. Header and trailer are there. Here in between the message is there. Same thing. But here we were talking about a particular byte. Here the sequence of bits are there, not a particular bit. Here the sequence of bit or sequence of characters are there, right? Now Here we need a delimiter to separate one frame for another. Obviously we need a delimiter. Now most protocol used 8-bit flag pattern. This is the 8-bit flag pattern. 1, 2, 3, 4, 5, 6, 7, 8. This is the 8-bit flag pattern. Okay. Now what is this happening? That this is used as the beginning and ending. So most probably this flag pattern is used as the beginning and ending flag pattern of your frame in case of your bit oriented framing. So this is the character which is used in most of the protocols. Now, if flag pattern appears in the data, the receiver must be informed that this is not the end of the frame. Same thing. But this is done by stuffing one single bit to prevent the pattern from looking like a flag. This is called bit stuffing. Here also we are giving one bit, right? Which will show that it is not a ending of the frame. Okay. So ending of the frame to not resemble this thing as the ending of the frame, again we are stuffing a bit here. That is bit stuffing. Okay, what is bit stuffing now? So that it will not look alike as a flag. Okay, so here process of adding one extra 0 whenever 5 consecutive ones follow a 0 in the data, so that the receiver does not mistake the pattern this for a flag. So here what will we do? That is adding one extra 0 whenever 5 consecutive ones after a 0 in a pattern follow a 0 in the data, so that the receiver does so. After 5 consecutive ones, a 0 is again added, so that it will not look alike as the flag. Again, if some 1 and then 0 comes, again it will look alike as a flag. So after consecutive ones, okay, so in bit stuffing, if a 0 here, process of adding one extra 0 whenever 5 consecutive ones follow a 0 in the data, so that receiver does not mistake this as the flag pattern. 1, 2, 3, 4, 5 up to this. If this happens, again a 1 comes, it will look like the flag pattern. So we will add a 0, a extra bit, so that it will not look alike as the flag pattern, right? So in bit stuffing, if a 0 and 5 consecutive 1 bits are encountered, an extra 0 is added here. So if a 0 and 5 consecutive ones are seen, then we will add an extra 0, so that it will not look alike as the flag sequence, right? Now this extra stuffed bit is eventually removed from the data by the receiver. What the receiver will do after he is receiving this data, it will think this as the again the escape character. So it will see this one and it will remove this data, and afterwards what it will do, it will take the again next data. Okay, the extra stuff that will be removed, and the extra bit is added after 1 0 is followed by 5 1s, regardless of the value of the next bit. Now what is the next bit? It doesn't matter. What will be the next bit? It doesn't matter. But the receiver is knowing that it is not a flag sequence. So obviously now if someone is coming, the receiver will not take it as the flag sequence. Since after 5 consecutive ones, if the receiver is getting a 0, he will not think this one. After removing that 0, obviously he will remove that 0 since it's an extra character, that's a stuffing done. But he will not, after this, if someone comes, then he will not take this as the flag character, right? This 0 is breaking this sequence. After this, it will not think. If 1 is also coming, this can come, but it will not think it as a particular flag pattern. Okay, so this is what is happening here. Now this guarantees that the flag field sequence does not appear in the frame. So what is the thing, that the flag sequence, it is for your header and showing the beginning and ending. The flag sequence is for your beginning. In the bit stuffing, that is a byte stuffing or character stuffing, and bit stuffing, what is the difference? Here we are having a flag sequence again here. So again here also we are having a flag sequence, but it will be 0, 1, 2, 3, 4, 5, 6, 7, 8. Again here 1, 2, 3, 4, 5, 6, 7, 8. So this is what is the difference. Okay, so in byte we are having 1 byte. Okay, so here this is the flag sequence. Here this sequence is our flag sequence. This particular sequence is called a flag sequence. This 8 bits, this is a sequence of bits, right? So this is what is here is as taken as the flag sequence. So this is the particular difference between them. Now here what we were doing, we were adding an extra byte so that it will not resemble the flag sequence. So here what we were doing, here whenever special byte, that is our escape character, was inserted, it was stuffed in this particular thing. If in between this particular flag sequence can be a portion of the data, so if this particular flag sequence comes in middle of this, the data of your information, then here in byte stuffing we were stuffing a particular one byte, that was the escape character, which will show that it is not a flag sequence, it's not the ending of my message, it is only coming in between, it's a portion of the message. So the receiver will remove this escape character and go to the next bit, whatever the next bit is, it doesn't matter. Same thing here also, if this particular sequence comes, so after 0, if consequent 5 ones are coming, then what will happen, if again an extra 1 comes, then it will take this as the flag sequence. So to not resemble this particular thing to the flag sequence, what will we do? After 0, if 5 consecutive ones are coming, we will add an extra 0 here, which will show that this is a ending, this is not a ending of our sequence, it's not resembling the flag sequence. After this 0, the receiver will get and he will remove this one, and if afterwards some 1 is there, it doesn't matter. Now the receiver will not resemble this, since he is getting a 0, particular 0. After this, if he is getting a 1, he will know that this, after 5 ones, if some 0 is coming, then this is my escape character, that is, this is my character which I have to remove. I have not to take this character, he will remove that character and go to the next character. Next character, next bit can be a 0, can be a 1, anything, but it will not resemble to the flag sequence. This is the thing which is very important in framing. Data link layer is basically totally dependent on this framing. So whenever you are going for the framing portion, 2 kinds are there, that is your bit stuffing and your byte stuffing or your character stuffing, and this thing is very important for your exams also. This is the portion, if you will understand nicely, you can get good marks in your competitive examination or your semester's examination. So please understand this one, try to understand this one. If you have any queries, you can feel free to ask me in my comment section. And if you want me to explain any other topic from this particular networking or any other subject of our CSC, so you can ask me that also. I will try to explain that one. So till then, this particular portion is very important. This framing chapter is very important in your data link layer. Particular layer, the framing is everything. The framing size, the frame size, and these particular stuffings are very important topics. So try to learn this nicely, try to understand this. If you have any queries, please ask me. I will tell you how you have to solve that problem. Okay, till then, if you like my channel, then please subscribe, give a like, and just share it with your friends also. Till then, take care and goodbye.